Today we are going to talk about the unit circle and how it relates to the 6 trig functions we have been studying. A circle with a radius of 1 is the unit circle. The ray at which an angle of rotation begins, usually when we draw an angle, you have a beginning point and an end line. The beginning line is called the initial side. The ray where an angle ends, the other side, is called the terminal side. When the vertex of an angle is at the origin and the initial side is the x-axis, that's called standard position. And that's how we always draw our angles. And when we get to drawing angles, I will show you more today of what I mean by that. Alright, so this is just a little bit of review. Remember, sine of theta is equal to opposite over hypotenuse. In this particular triangle on the right, which is in our unit circle, the opposite is y and the hypotenuse is 1. So, if I'm in a unit circle, sine of theta is just equal to whatever my y value is. Cos theta, remember, is adjacent over hypotenuse. So adjacent over hypotenuse will be x over 1, so it's just an x. Tangent is opposite over adjacent. So opposite over adjacent is y over x. So in a unit circle, tangent will equal the y value divided by the x value. Cosecant is the reciprocal of sine, so it's going to be hypotenuse over opposite, which is just 1 over y. Secant's the reciprocal of cos, so it's going to be hypotenuse over adjacent, which is 1 over x. And tangent's going to be cotangent's the reciprocal of tangent, so it's going to be adjacent over opposite, which is x over y. And another piece of information that's going to help us today are the signs of the 6 trig functions. Now, this is not the easiest thing in the world to do, but we'll do our best. Okay, notice the picture on the left-hand side here. A in quadrant 1, 2, 3, and 4. In quadrant 1, everything is positive. So I'm just going to put a little, like, all. All is positive. S stands for sine. So in the second quadrant, sine is positive, but its reciprocal will be as well. Everything else is negative. T is the tangent. So in quadrant 3, tangent will be positive, and its reciprocal, and everything else will be negative. And in quadrant 4, the C stands for cosine. Cosine and secant, its reciprocal, will be positive, but everything else will be negative. One way to remember the order, my teacher told me in high school, was that all seniors take calculus. Or another thing I've heard is a silly trig class. However way you remember it, you just need to remember it goes A, S, T, C. What we have to figure out is the quadrant in which an angle is in, given the following information. So what I'm first going to do is just draw an axis with an ASTC. It tells me first that sine has to be positive. Well, and I'm going to go through. Is sine positive in A? It is, because everything's positive. Is sine positive in S? Yes, because that's what the S stands for. Is sine positive in T? The answer is no, only tangent's positive, so we're going to cross it off. Is sine positive in C? The answer is no, only cosine's positive there, so we're going to cross it off. Then I look at my other information. It says cos has to be positive. Is cos positive in A? Yes, it is. Everything's positive. Is cos positive in S? No, because only sine's positive there. So since I said no, I'm going to cross it off. I can see I'm in that first quadrant, so I'm going to say quadrant 1. Remember, we label our quadrants with Roman numerals, not with actual numbers. Let's look at the next one. It says secant has to be positive. I don't like thinking of reciprocals. I like thinking of the normal ones. So I know if secant is positive, that means that its reciprocal, cosine, also has to be positive. And this is saying tangent has to be negative. So we'll draw Now that we have our axes, let's go through the process. Is cosine positive in A? The answer is yes, everything's positive. So, ask our next question, is cosine positive in S? The answer is no. So we cross it off. Is cosine positive in T? The answer is no. Only tangent's positive there. Is cosine positive in C? The answer is yes. Now tangent has to be negative. Is tangent negative in A? The answer is no, because everything is positive in A, so tangent can't be negative. And is tangent negative in C? The answer is yes, because the only thing that would be positive in there is cosine. So I am in quadrant 4. I'm going to have you guys try that third one. Okay, moving on. I'm telling you, you have this point on a unit circle. The important piece here that it says is that we are in a unit circle. Find all 6 trig functions. And this is pretty easy because we're in a unit circle. If you're looking back at your chart above, sine theta is equal to the y value. Well, what's the y value at this point? It's just negative 12/13. Cosine is equal to the x value. Well, the x value is negative 5/13. Tangent is equal to the y divided by the x. In your calculator, take negative 12/13 and divide by negative 5/13. You'll get 12/5. Cosecant is the reciprocal of sine, so instead of being negative 12/13, it's going to be negative 13/12. Secant is the reciprocal of cosine, so instead of being negative 5/13, it's going to be negative 13/5. And cotangent is the reciprocal of tangent, so it's going to be 5/12. Let's look at our next one, and I'll leave the third one for you guys. So the next one, sine theta is going to equal the y value. Cos theta is going to equal the x value. Tan theta is going to be y over x, and I'll show the work here. So it's negative 2 radical 5 over 5 divided by my x value, radical 5 over 5. I can do a state change flip here. So keep the first, change division, multiplication, and flip the second. You should notice here that 5's cancel, radical 5's cancel, so you're just left with a negative 2. Cosecant, flip the fraction. So cosecant is going to be negative 5 over 2 radical 5. Now what's wrong with that? Should be telling me there's a radical in the denominator, and that's not allowed, so let's multiply by the radical 5. So we get negative 5 radical 5 over 10, which reduces to negative radical 5 over 2. Same idea with secant. Secant is going to be 5 over radical 5. And let's rationalize by multiplying by radical 5. So we get 5 radical 5 over 5, which reduces to radical 5. Luckily for us, cotangent won't be as bad. Cotangent, you just got to flip negative 2, so it's going to be negative 1/2. Hopefully you guys have room to continue or to try that third problem there. And finally, for this last piece, for each given angle, determine to the nearest tenth the coordinate of the point where the terminal side intersects the unit circle. So 229 degrees. If I graph 229 degrees, it's down there. I want to find the point that it hits on the unit circle. The way I do that is I know sine of my angle. So sine of 229 degrees has to equal my y value. And cos of 229 degrees has to equal my x value. Well, when I type sine 229 in my calculator, it gives me negative 0.8. When I type cos 229 in my calculator, it gives me negative 0.7. So my point, remember it goes x comma y, is negative 0.7 comma negative 0.8. Let's try 312 as well. We know that sine of 312 will give me my y value. So sine of 312 is negative 0.7. Cosine of 312 is my x value, and that equals positive 0.7. So my point is 0.7 comma negative 0.7. I want you guys to try the 45 degrees as well, and we'll continue this stuff tomorrow.